In this particular question, we have to find the approximate value of the cube root of 127 using the binomial theorem. So first, we can rewrite the cube root of 127 as 127 raised to the power of 1/3. Now, we can go ahead and decompose 127 into two parts. 125 added to 2 gives us 127. Now, when we factor out 125, this number was chosen because we know that 125 is a perfect cube. So when we factor it out, so we'll have 125 raised to the power of 1/3 times 1 plus 2 divided by 125 raised to the power of 1/3. Then this becomes 5 times 1 plus 2 over 125 whole raised to the power of 1/3. Now, the second reason for considering 125 plus 2 is because now we also have to keep a check of the fact that the absolute value of 2 over 125 must be less than 1, and that's always true. This is a number which is going to be less than 1. Now let us go ahead and apply the binomial theorem. So we have 5 times 1 plus 2 divided by 125 whole raised to the power of 1/3. So that gives us 5 times 1 plus n, which is going to be 1/3 times x. So we have 2 over 125 plus 1/3 times 1/3 minus 1 divided by 2 factorial times 2 over 125 whole squared, plus we'll consider one more term, that will be the fourth term. We have 1/3 times 1/3 minus 1 times 1/3 minus 2 divided by 2 factorial times 2 over 125 cubed times added the rest of the remaining terms. Now we will simplify it, so that should give us 5 times 1 plus 2 divided by 3 times 125 gives us 375. Then we have minus, so we go ahead and use a calculator, and this value will be 4 divided by 140,625 plus the fourth term, which will be equals to 8 divided by 316,40625. So this is the value. Then we do further more simplification. This will be 5 times 1 is 5 plus 5 times 2 is 10. 10 over 375 minus 5 times 4 is 20 divided by 140,625 plus 5 times 8 is 40. 40 divided by 316,40625. We do the final calculation, and that gives us 31808,483 divided by 6328125, and when we divide this number, that gives us 5.0265. So this is correct up to up to 4 decimal places. So this is the value of the cube root of 127, which we found out by using the binomial theorem. Let us do another problem. So in this question, we have to find the approximate value of 0.98 raised to the power of -3. So let's try to find it out. So we have 0.98, so we can instead write it as 1 minus 0.02 raised to the power of -3. So here we have the absolute value of 0.02. Negative 0.02 is less than 1. So this is why we have taken 0.9 as 1 minus 0.02 instead. Now we'll use the binomial theorem, so that gives us 1 plus n times x plus n times n minus 1 divided by 2 factorial times negative 0.02 squared plus n times n minus 1 times n minus 2 divided by 3 factorial times negative 0.02 cubed plus the rest of the remaining terms. So that would give us 1 plus 6 divided by 100, which we can write as 10 squared. This particular value will be 24. So you can use a calculator, and that should give you 24 divided by 10 raised to the power of 4 plus the fourth term, which is going to be 80 divided by 10 raised to the power of 6. Now we're going to add this value using a calculator, and that should give us it's giving us 1.06248. So we can say that the value of 0.98 raised to the power of -3 is approximately equals to 1.0625 up to, corrected up to 4 decimal places. Let us do another problem. So we have to find out the approximate value of 1 over cube root of 0.998. So let us first simplify the given value. So we have 1 over 0.998 raised to the power of 1/3. When you take it to the numerator, we'll have 0.998 raised to the power of -1/3. Like the previous problem, we can write 0.998 as 1 minus 0.002, -1/3, or we can simply write 1 minus 2 divided by 1000, which is going to be 10 cubed, raised to the power of -1/3. So now we will expand the value of 1 minus 2 divided by 10 cubed raised to the power of 1/3. So that gives us 1 plus n times x plus n times n minus 1 divided by 2 factorial times x squared, and a fourth term, which will be -1/3 times -1/3 minus 1 times -1/3 minus 2 divided by 3 factorial times -2 divided by 10 cubed raised to the power 3. So we're going to consider only the first 4 terms, and this is going to give us 1 We have 1 plus 2 divided by 3 times 10 cubed plus 16 divided by 18 times 10 raised to the power of 6, and the final term is 28 divided by 162 times 10 raised to the power of 9. Now we can use a calculator, and that should give you 1.000667. Now this is an approximate value, corrected up to 6 decimal places. Now you can check your calculator and also check what's the value of 1 over cube root of 0.998 is, and it is going to be approximately equal to the value that we have found using the binomial theorem.